Okay, welcome everyone. So in this particular video I will be explaining the problem statement and the observation solutions of this problem prefix suffix min max, and this is of the starters 155, right? So the problem statement is as follows, that we are given, and let's say there is an array A with integers element of size n, and then we created another array B, and B is such that we take the prefix sum up to the ith element. Let's say if you want to compute the ith element of B, then you take the prefix sum up to the ith element of array A, and you subtract it with the max element up to index 1 to I of array A, right? So I should write this here. Our B is constructed such that there is a array B, and for the index I of array B you take the prefix sum of A up to I, right? And you subtract this with the max element of A from 0 to I, right? And I can write something like this. Instead of this prefix sum, I can write sum of elements of A 0 to I, right? So this is how you construct your ith element of array B, right? So if we go ahead, then the thing is, we are given array B and we have to find any valid answer for array A, and it is guaranteed that the B will be given such that the answer will always exist, right? So the input is pretty much simple, that we have number of test cases 3, and in each test cases we will be providing with the integer which represent the length of array B. So this is 3, and the array elements are 0, -2, 1, and we have to output the corresponding answer for the array A, right? So let's jump on to the observations, right? So let's say if I wanted to find what will be the first element of the array A, so I will have B0, and the sum of all the elements from 0 to, oh, there is 0, I have written, oh yeah, so sum of all the elements from 0 to 0 will be obviously A0 minus, then the max element from 0 to I, so I is 0 here, so this will be also A0, right? And this came out to be 0, then B0 will always be 0. So can we cross check this, right? So in the example test cases, we are always given an array B such that the answer always exists. This is written here in the note, right? So the first element of B will always be 0. You can see 0 is here, 0 is here, and 0 is here, right? So which is seem pretty much obvious, right? So you see that there is no boundation on the first element of array A, right? Because whatever the first element of array A0 minus A0 will always be 0, right? Then this condition will always satisfy, right? So I should write, there is no bound if you only take first element of A, right? Now consider this, I have to construct the solution to my answer, and let's say there is a very much important role here. Sum is something which we know it can be generated, right? But think of the max element, this can vary throughout the array. So I wanted to make one observation here. I want to make one observation is which is, if there is no bound on A0, then I consider A0 as the maximum element is the maximum element of array A. So this is my assumption. Always remember this assumption, right? Now I will rewrite the same condition for you. I will rewrite the same condition here. I will just copy this. I will rewrite it here, right? So element bi equals to the sum of all element 0 to I minus max element 0 to I. Now we know a0 is the maximum, so you can simply replace this with a0, because you know a0 is the maximum element. We have considered this in the assumption here, right? Now the sum of elements of a0 to I, this can be now transformed to, you know, the sum here is 0 to I and you're subtracting with a0, then the sum is left with 1 to I, right? The sum of elements of A is now 1 to I. Now your problem statement is very much simple. Basically your equation is very much simple. Your bi is reduced to this particular thing, right? Now see how much simple thing we are left with now. So bi is basically sum of elements of A, which is 1 to n, right? Now consider this. I have to find the last element. Let's say if I start with finding end elements of array A, right? Now let's say if I have to find the last element, which is, let's say, A, so this is the index, this is the subscript, okay? So A n minus 1, I have to find the last element of my array, right? How can you find this? As you know, you have every element of bi, right? Now what you can do, you can think like this. Let's say if I take, let's say if I have sum of all the elements up to n minus 1 and I subtract this particular sum with all the elements up to n minus 2. So this is the thing. After doing this, if I have sum of all the elements from 1 to n minus 1 and I subtract this by the sum of all the elements of 1 to n minus 2, what will be I left with? I will left with A of n minus 1. This is simple mathematics, right? Now you can simply write A of n minus 1 is simply b of n minus 1 subtracted by b of n minus 2. So as you know that this particular thing is this, right? And this particular thing, this particular thing, this one is this b of n minus 2, right? As we are following this equation, right? So now similarly, if you want to find let's say the ith character of the array, right? Then you can find it like this. You have b and you subtract with bi minus b of I minus 1. So this is in subscript, right? So for finding the ith element of A, you can do like this, right? Yeah, so using this equation you can find the ith element of array A. Now remember that you have now also remember that you also have to find this up to I greater than 0. You should do this from I greater than 0 and not for I equals to 0, because you know for I equals to 0 there is no bound on a0 and you have made this first assumption that you are considering a0 as the maximum element of the array, right? Now how will you put the value of a0, right? Now you have, let's say if you have find all the answer, you have found all the answers for a, let's say a1 to a n minus 1. Now take the max of them, and let's say that max is mx, right, and a0 will be more than mx, so you can just replace a0 by mx plus 1, right? It can be more than, but it can be more than 8, but just replace it with mx plus 1. So in this way your a0 will be the maximum element of the array. So this is a pretty much simple solution to this problem. Now I will show you the code, but I hope that up to this point you guys have understood yourself, right? Just look at my code now. Yeah. Now consider this. I have taken the input of n, and I have taken the input of array b in this format. So I'm using this particular feature. This belongs to my boilerplate. So for this you can check my boilerplate video. I have provided the code for my boilerplate. There is amazing features as well. You can just take a look at it, right? Now I have written a edge case here. For n equals to 1, we can simply output the array element as 0. We can output anything else, it don't really matter because we have no bound on element a, right? So this is the base case here, right? And yeah, now I wanna now if this is the base case, then I can simply move on to the next case here. Now let's say if you consider the main cases, you make a vector, you make a vector a where you will populate the values of a, and you make a max, and you take the max as you calculate the indices from the back. Now I'm running this particular loop from the back side, right? I'm going from the last index to the second index, right? I'm not considering 0. I'm not going to the 0, right? Now I'm running this loop backside, and I'm simply applying this equation which I have showed you in the notes here. I'm just applying this equation, right? And I'm getting the answer of ai, and as soon as I'm getting the answer of ai, I'm taking the max because I'm storing the max element here, right? What is the max element? And I have initialized it with the int min, right? And after calculating the max element, I can put the value for a0 as max element plus 1, and I can simply output my answer. So this is a very simple solution. I hope you guys understood, right? And I will provide the code for the same in the description, and also my boilerplate code, and you can also check out my boilerplate video, by the way. Yeah, thanks.